Alrighty, so good morning. Happy Thursday. Hopefully, everybody's having a great start to your day. Today, for AP Computer Science A, we are going to do just pretty much what we've been doing the whole time, go over some free response questions. I did post the link in the chat just now for Mr. Ferreira or anybody else that needs access to it. Per request, which I think is definitely a good idea, I went ahead and posted these in advance, and I think it's probably helpful for you to all be on the document at the same time so you can sort of read and follow along. I think that's probably a little bit of a better idea than just going ahead and trying to tackle them on the fly and being like, oh, do you understand this scenario on the fly? And some of you might be like, not. Some of you might be like, yeah, but some of you might be like, not really. I kind of need more time to read and digest it. So that's why I posted it yesterday. So hopefully you could take a look at it, read it if you needed to read it, and understand what's going on. I think one thing about the two questions that I've specifically selected to present to you today is that their scenarios are complicated, but the actual solutions are not. The actual tasks that you're being asked to do are fairly, fair. I don't want to say easy because I don't want to make it sound like it's not difficult, but they're fairly what you should, I guess, the difficulty that you should expect for a class like this. Given this like big paragraph long scenario, you might be like, oh geez, this is going to be one of those crazy problems where I have to come up with some crazy solution. But then when you actually read the instructions in the actual task that you're asked to do, you're like, wait a minute, that's manageable. I can do that. That's not too bad. Okay, so that's the point I really wanted to emphasize with you today, is because I feel like out of the two free response questions, I think at least one of them, probably the second one, is going to be like that. It's going to be a question where it's going to give you this big, complicated scenario. Now, I haven't seen it. I don't know for sure. But I can imagine it in my head that it's like it's going to give you this complicated scenario, and then it's going to be like, all right, write a method that, adds up all the numbers in an array. And it's like, oh, I can do that. So make sure that you do not get overwhelmed by the actual scenario. It's important to read it. It's important to understand the context of what's going on, but don't get like crazy and overwhelmed and all crazy about it. All right. One other thing that I want to make sure I remind you before I dive into these two questions that I have for you today, if you want to open up the questions in another tab, that's a great idea. I want to remind you that today you are going to receive an email at the end of class. It's scheduled to go out at 11:10 a.m. right at the end of class for your first assessment. It is a practice free response question that I've created for you. I think it's a great example of a free response question that you could be expected to see on the AP exam. So I am going to ask that you complete that and send it back to me via email. You can go ahead and make a copy of the document that you're going to get via email in just a little bit, about 25 minutes, and type your code in that and share the completed document with me. If you prefer to write it out by hand, you can go ahead and write it out by hand and then take pictures of your work and send it to me via email. But however you decide to submit it, I do ask that it is submitted by 11:59 p.m. on Sunday. That way I can spend Monday grading it and getting you feedback and making sure we can get ready for Tuesday's class. I feel like if I made the deadline to be on Tuesday, then now we're going into class, I have to grade the stuff still, and then it just lags us behind, And I think that Sunday night deadline is plenty of time. That's Thursday afternoon, Friday all day, Saturday all day, Sunday all day to get done, which should take maybe about a half hour, if that. Okay, so that's the idea. If you do have any questions, though, you can always feel free to reach out. Particularly on Friday, we do have that time that I am here. I'm at my computer. So if you just send me a Google Hangouts message and you're like, Mr. Giorgio, can you jump in the meet for a second? Because I have a question on the AP problem. Absolutely, 100%. I'm here. So please, please, please don't hesitate to reach out. So that being said, let's go through some problems. Sorry, one more thing. Make sure you check out that Code HS if you haven't checked that out yet. I also posted in our Discord server together. I don't know if you actually saw that. I know some people aren't particularly active on that, or maybe don't monitor it regularly. We do still keep around, for whatever reason, we still keep around people that have taken the course in previous years, and hopefully you've been using them. I know that there's definitely been a couple instances of that this year, where people have been reaching out to those veterans of AP Computer Science A to ask them for homework help, or can you clarify this, or something like that. I did schedule that on I just bringing up my calendar now right here. On Friday, May 1st, from 2 o'clock p.m. to 3 o'clock p.m., we are going to have like a little conference call within the Discord. I know it's not called a conference call, calling it a conference call. It's just a Discord call or a voice channel, whatever. Not trying to sound old. We are going to have a little call with everybody just for them to provide you with some wisdom or some advice for the AP exam. If you have any questions that you want to ask people that have taken the exam last year about the exam, I think that's a great opportunity for you to do so. If you are not able to attend, but you still want to ask them questions, that's again Friday, May 1st from 2 o'clock to 3 o'clock p.m. If you're not able to attend, but you still want to ask questions, just email me the questions you want to ask, and I'll be sure to relay that to them and get their responses. Okay? So if you can't attend, that's fine. It's totally optional. It's not something I'm requiring you to do by any stretch. It's just a great little chunk of time that I've tried to set aside to make sure we can get some good work done and get some good conversation going and just catch up with everybody and see how everybody's doing in these times. All right, with all that explanation out of the way as a long-winded introduction, let's go ahead and get started with actually jumping into some free response questions. So starting with question 1 here. Question 1 is talking about an AP calendar. It contains methods used to calculate information about a calendar. Hopefully you read this over yesterday. If you didn't get a chance to, hopefully you're reading through it now. It has a couple methods here, a couple methods to say, is it a leap year? It takes a year and determines whether or not that year was a leap year. Notice that the implementation is not shown. It's not important that you know how that method works. The method works. That's what you need to know. This method returns true if you pass in a leap year and false otherwise. So you don't need to know the intricacies of how that happens. You could actually probably code that very easily, though. You just go ahead and mod 4, see if it goes in evenly. But you don't need to know that. You just need to be able to implement that and use it in your actual methods. Second method we have here is what we're going to be working on in Part A. We have to determine the number of leap years between 2 years. So the precondition is that year 1 is in fact less than or equal to year 2, so you don't have to worry about going backwards or forwards in time. You don't have to worry about swapping them if they're out of order. You can assume that year 1's less than year 2, and we just have to determine the number of leap years between them. That's a fairly straightforward idea. Okay. Next, we have another method called, this will come in for Part B, the first day of the year. It tells us if we pass in a year, then it'll say, hey, the first day of that year was on Tuesday or whatever day. And then we do day of year. So if we pass in month, day, and year, it tells us, hey, that was the 60th day of that particular year. And we're going to use both of those methods in Part B, okay, to actually figure out what day of the week any specific day falls on. All right. Before we get to that, though, let's go ahead and try to write number of leap years. So number of leap years, all we're doing is we're given 1 year and we're going up to the next year, and we're just trying to determine how many leap years are there in that span. So what I would be inclined to do is let's keep track of how many leap years there are. I'll just start with int leap year is 0, right? Int leap year. And then I can go ahead and make a loop. I can say for int I equals, let's start at year 1. Let's go up to year 2. Does this include year 2? Yes, inclusive. So that's why I made it less than or equal to. And then I++. Starting at year 1, going up to year 2, we can say if, what do we have? Is leap year right here. See this method? If this year is a leap year, so if is leap year at index I is true, then I'm going to increment my leap year counter. And that's, I think, pretty much it, right? And I'm going to return leap year. Okay? Mr. Ferrer, I don't know if you can think of anything else to go with that, but I think that pretty much does what it needs to do, right? Or anybody else here? Does that sound good to everybody?
Yeah, that looks good. I'm mute. Sorry.
Yeah, no problem. Nice simple little loop here to say there are 0 leap years. Let's go from the first year to the second year and just check if each one is a leap year. Then we're going to increment the counter, and we're just going to return the counter. Okay. So again, I think that's a prime example of the fact that, yes, the scenario is this big long paragraph of text, but the actual method is literally just a for loop, is the response to that free response question. Okay? The next free response question is a little more complicated. We have to write a method called day of the week, which returns an integer representing the day of the week for a given date. So where 0 denotes Sunday, 1 denotes Monday, and so on to 6 being Saturday. So if we pass in any month, day, year, we should be able to say what's going on. Okay? 2019 began on a Tuesday, and January 5th is the 5th day of 2019. As a result, January 5th, 2019 fell on a Saturday, and the method called day of week 1/5/2019 would return 6. So I always like that it gives you an example, nice and clear as to what this method should be able to do. Now, we do have two methods to help us out here. We don't, again, need to know how they work. We just need to know that they work and what they do. We have this method called first day of year, which if I pass in the year, it's going to return an integer value representing the day of the week for the first day of the year, right? So that's probably going to be useful to say, hey, if the user passed in 2019, for example, I want to know what day did 2019 start on. That's probably going to be a useful thing. We also have day of year, where it returns n, where month, day, and year specify the nth day of the year. So January 1st would mean that month is 1 and day is 1. The value 1 would be returned. Okay? Hopefully that makes sense. It does account for leap years within the actual method itself, so we don't need to worry about doing the is leap year method. Presumably that call would take place somewhere inside the functionality of day of year, so we don't need to worry about that. Okay? I always like that the AP exam does give you this as well. It always gives you the little toolkit of what you have to work with, so you could always say, hey, I have this nice little toolkit of stuff. I want to make sure I use that stuff in order to accomplish this. Okay? So let's actually see how that would happen. All right. So if I'm going to go ahead and actually find what the day of the week is, what I would think of is, I'm thinking, how would I actually do that? Well, what I would probably do is I'd probably say, well, what day of the year did we start, or what day of the week did the year start on? Like, did the year start on a Wednesday? Did it start on a Thursday? Did it start on a Friday? I would like to find that out. And then I'd like to find out, well, how many days since the start of the year has it been? Because if it's like, oh, we started on a Wednesday and it's been, for example, 49 days since that day, well, then we're just back on Wednesday because weeks repeat in cycles of 7, right? So by doing that and extracting that information, that is how you can determine what day of the week we're on. If it's been 50 days, well, we can say, oh, it's 49 would be a total of 7 weeks, and then plus an additional day, so I'd be on Thursday, for example, or whatever. So let's first figure out, sorry, I just had my text all modified and then I changed it. Let's first determine what day did the year start on. So we can just do that by passing in year into first day of year method. So I can say something like int y equals, or is it y, or let's say first day. So let's call it day, or d for day, because we already have something called day. Int d equals first day of year, and then pass in year. So we now have this variable called d, which will tell us when the first day of the year was on. What number day is that? Okay. I'm then going to try to say, well, what day of the year are we on? So we could also have int day of year, and maybe we'll set that equal to, let's pass in the actual month, day, and year here to see how far we are. So it's called day of week. Or day of year, right? Day of year. And let's pass in month, day, and year. All of those things are provided to us, so we can just go ahead and pass those in right here, because they're going to be provided in the method, month, day, year. So now I know what day the first day of the year was on, and what day of the year we're on now, so we can just go ahead and figure out what day of the week any given day is on. Now, you may keep in mind that maybe what you'd be inclined to do is say, let's call it int day of week, is let's take the first day of the year and just add on however many days of the year there are. But then what would I actually need to do with that calculation? If I'm taking the day we're on and I'm adding on the number of days, what do I actually need to do with that? Does anybody have an idea?
You'd probably want a mod, right?
Yeah, something to do with a mod, right? Because mod by 7 would say, well, let's account for the fact that every 7 days we just cycle back to to where we started, right? If we started on a Tuesday, every 7 days from there, we're back to Tuesday. Okay? So I would do my first day of the year plus however many days we've progressed, mod 7, but there is one little bit missing. Keep in mind that day of the year, if the day is January 1st, then day of the year would return 1. If I'm finding out that my first day of the year is, say, on a Tuesday, and day of the year returns 1, I don't want to do Tuesday plus 1 to end up in Wednesday. Do you know what I mean? So what I'd have to do to this calculation is just subtract 1 to account for the fact that January 1st is really 0 days since the start of the year. This method, day of year, even the way it's defined up there, it returns 1 for January 1st. Or anything like that, right? January 2nd, in this method, day of year, would return 2. But January 2nd is really only 1 day since the start of the year. What you could do to account for that, instead of putting the -1 here, you could put the -1 here, if you wanted to, and then you would just be able to do that. That's absolutely fine to say, well, how many days have passed? Maybe you could call that days past, and then add it up like that. But either way you decide to do it, we do need to subtract 1 to account for the fact that the first day of the year is not actually 1 day since the start of the year, it's 0 days since the start of the year. Does that make sense to everybody? It's a weird technicality, but it's important. Okay. If you didn't put that -1, by the way, on a free response answer, it's important to note, it doesn't mean that the whole thing would be marked wrong. It would probably just get maybe a point off or something like that. But you definitely still get the large majority of the credit for your response like that. And then the last thing we have to do is just return that value. So if you wrote that and you just figured out that, hey, I want to add those up in mod 7, you would get probably like 8 out of 9 points or something like that. That would not be a problem. But doing that is what you really need. Oops.
Quick question, Mr. Giorgio.
What's up?
So calling the local variable day of year, that wouldn't give us a compiler error?
Oh, because the method's called day of year, right? I didn't even think about that. It probably... I don't think it would give a compile error because I think since this is a variable and this is a method name, but definitely probably a good idea to just avoid that by calling it, I don't know.
Or throw an I in front of it, I day of year or something.
Yeah, something like that. Call it like day year or something like that. Sure. Sure. Definitely a good idea to avoid the fact that these two are the same name. I didn't even notice that. I appreciate you pointing that out. Anything else from there? And actually, this is true too. See, day of week and day of week probably should share the same name. Let's call it day week.
Right.
Something like that. You know, commonly probably referred to as weekday in common speak, but you know, programmers, day week. Any question about that?
Nope.
All right, cool. So again, definitely look these over. Make sure if you're listening right now and you're not really understanding, this is why I wanted to share the document with you ahead of time and also give you access to it to make sure that you can go back and check those things out. All right, let's go into question 2. So, question 2 says, consider a system for processing student test scores. Not surprisingly, if you do actually take a multiple choice test, like for example the AP test, this is actually how your scores are calculated. Not with the same point values and whatnot. I think the point values actually correspond to the old way the SAT was scored in this particular example. Not that you need to know that, but this is actually how it's done. Like there is some program out there that just reads your string of answers, compares them to the correct answers, and determines your score. It's not someone sitting there by hand. So anyway, it says, this class will be used as a system that contains a student name and the student's answers for a multiple choice test. The answers are represented as strings of length 1, with an omitted answer being represented by a string containing a question mark. So it looks like everybody can respond in a multiple choice way if you look at the images down here. But they could also have a question mark to say they don't know. And in this particular scenario, a student's score on a test is computed by comparing the answers. 1 point is rewarded for each correct answer. 1/4 of a point deducted for each incorrect answer. And omitted answers do not change the score, so they just get 0 points. Okay, so sometimes, especially that was the case on the old SAT, where sometimes if you couldn't narrow it down, it was actually a little more beneficial to just not answer as opposed to risking losing points. But nowadays, the SAT has no penalty for guessing and getting it wrong, so it's always worth it to guess. Anyway, not relevant. Let's see what this student answer sheet thing looks like. So we have our array list of strings called answers. This is a list of the student's answers. I also have a method that says get score if you pass in the answer key. So if you provide it with the key, it's going to compare the actual answers that the students provided and determine the score. That's what we have to do for part A. So before we get into part B, let's just figure out part A. So it says write the student answer sheet method get score. The parameter passed to the method get score is an array list of strings representing the correct answer key for the test being scored. The method computes and returns a double that represents the score for each student's test answers when compared with the answer key. 1 point for each correct answer, a fourth of a point for each incorrect answer, and omitted answers get no score. All right, so let's go ahead and start. If I'm going to go ahead and write this, I probably want to start with their score being 0. So I'll start with double, because we can have decimals. Double score is equal to 0. Okay, let's just start with 0. All right. Let's now go through the array list. Since the array list of their answers and the key are the same length, it wouldn't particularly matter which one you specify to be the end of the array. I'll say for our purposes, it's just the end of the student's answers. So I'll say for int I, I already typed 4, int I equals 0. I is less than, what's it called, answers dot size, because it's an array list, and then I plus plus. And now we pretty much just have a bunch of if statements to say, well, if the answers match, then we're going to give them a point. If the answer is a question mark, then we're going to just ignore it. And if the answer is a incorrect, then we're going to subtract a quarter of a point. So we're just going to do a bunch of if statements. I'm going to say if, let's see, I want to say answers dot get I. Let's do if they're the same. Let's do if the person gets it right first. Dot equals key dot get I, right? Notice how we had to put dot equals because we're comparing strings, right? We're not comparing integers, so we can't use the double equal sign. We have to say if they're the same, then I can say score plus plus. So that would be if the student got it right, I can increase the score by 1, right? Otherwise, I can say, well, if answers dot get at index I. Now, what if they put a question mark? What if they omit the problem? We can say, well, if that equals a question mark, I can actually just do nothing. I can say I probably wouldn't even put anything in there. I'd just leave it empty because you're really not modifying the score at all. But I think that's an important thing to have in there because if the actual student put a question mark, you don't want it to mark it as incorrect. You don't want it to say it's wrong. So I think that's an important actual thing to put in there. I mean, if you want to put, just for the sake of it, that score just stays the same, then that's fine. But I think it's important to actually put that if statement in there to say we don't want to change their actual score if they put a question mark. But lastly, we do. What do you got, Mr. Ferreira?
Real quick, Mr. George, a good practice is to actually just put a comment to say doesn't change or something.
Oh, that's good to know. Yeah, that's a good idea. Industry, yep, no change.
Yeah.
Something like that.
Change. Perfect.
Cool.
Yep.
And then something, that's a good idea. And then something like else if answers dot get index I is not equal to, so we can really literally just take this and do the opposite. So if that's not the case, then we want to subtract a fourth of a point, right? You could say score minus equals 0.25. Or if you want to do it, type it out, that's totally fine. Score equals score minus 0.25. All right, and then after all of that, we can go ahead and return the score. And I think that would get it done, right? That adheres to all of our rules, that if they get it right, if the answer at that position matches the key at that position, then we increase the score by 1. If they put a question mark, then we don't change it. I like Mr. Ferrer's idea, actually just put a comment to say there's no change. And then we could say if that's not the case, if they don't equal, then we can say score equals score minus 0.25. I suppose, I'm trying to think if you could just put else. I think you probably could just put else and not actually put that if statement, because if they're not the same and if it's not a question mark, then therefore it's wrong. So I think you could probably eliminate the last if statement and just put else like that.
Yeah, that's a good idea.
Yeah, but otherwise, but you could put the if statement in there if you wanted it to. It doesn't matter. Okay, I'll leave it there just so you see it. Any question about that? Actually, I'll put a little comment here just to remind you. Say or just else. All right, cool. And last but most certainly not least, we had part B. Part B was, I'll push it to the next page just so you see it. It said, consider the following class that represents the test results of a group of students that took a multiple choice test. So now you have this other class called test results. It literally takes an array list of answer sheets and pretty much wants to determine what the highest scoring student was. So we have this whole big array list of answer sheets. So now an array list of these, and we're saying which student had the highest score. So in order to do that, that sounds like something that would be a little complicated, but it's not that bad. It really just consists of another loop. So let's go ahead and do it. What I'd want to do is I pretty much want to go through all of the answer sheets. I can run it through the method that I just wrote called getScore to determine what the score actually is for all of those answer sheets. Then I can also keep track of what the maximum score was. We've done a ton of problems in this class of finding the largest value in an array or an array list, right? It's really the same idea, it's just applying it to a different situation. I also like the fact that on the AP exam you'll see this a lot, and it's a good indication that you'll probably need to use the method from part A in part B. It says, in writing highest scoring student, assume that getScore works as specified regardless of what you wrote for part A. That is often a key indicator that you'll need to use that actual method in this implementation. So what I would do, again, we're just trying to find the highest score in a list. In order to do that, I'm going to say double max score. Let's start it out as the first position in the array list, right? So I'm going to say, what's the array list of students actually called sheets? So sheets.getScore at index 0. Okay, so we'll assume that the first student, see how it's called sheets? It's the array list of student answer sheets. We'll assume that the first student has the highest score. Now I can go through the rest of the list and I can say for in I is 0, I is less than sheets.size, I plus plus. Actually, we can start it at 1 because we already compared 0. And now I can say if let's see, I want to say sheets.getScore at index I. So we're going to get the score of the first student, get the score of the second student, get the score of the third student, etc., etc., etc. If that score is bigger than our max score, then I want to go ahead and update max score. So I want to say max score equals sheets.getScore at index I. Okay? And that's exactly the type of structure we've seen before to determine what the highest actual thing is in a list, the highest value. We're starting by assuming it's the first position. Assume that whatever's in the first spot has the highest score. If we go through the list and we find something that's bigger than that max score, well, let's update our max score to be equal to that. By the time you get through the loop, max score should represent the actual highest score in the list. Like this should be the highest student, right? So now what you can do is you can go ahead and search through your answer sheets array to find where that score is actually located. And then you can return and print out, I guess you have to return, not print out here, you have to return the string of that student's actual name. So now that I did find the maximum, I can say for in I is 0, I is less than sheets.size, I plus plus. Let's actually look for that student if sheets.getScore at index I equals max score. So I want to actually find where the maximum score actually is located. Then I want to return that student's name. So in order to get the student's name, I believe it says it up here with the actual method. It's called getName. So I want to say sheets at .get index I .get name. And I want to return that. So I can call it string high score equals that, and then return that. And I think as I'm typing this, I'm noticing the fact that my syntax, I think, for the array list is a little off, and I'm going to fix that right now. So the syntax for the array list, if I want to actually call upon the get score method in Sheets, I believe I have to actually access that thing first. I think I have to say sheets.get at index I dot get score, as opposed to get score I. I think that's what I have to do.
Yeah.
Is that correct? Yeah. And so I'm gonna adjust that right now. I have to say sheets.get at index I and then .get score, because I want to get the answer sheet at that position and get the score of it. Because if you notice the score, oh, we have to pass in the key in order to get the score, right?
Yeah.
Key. There you go. And then same thing down here. Kind of like that. Right? Is that the most efficient implementation? Probably not. But as I'm going through it, I think that is a logical order that makes sense to me. Let's actually find what the max score actually is, and then let's go through the list to locate that max score and get the student. Does that make sense? Is there a way to clean that up? Probably, but I think that works for our purposes, right? Does anyone have a question about that? Makes sense, hopefully. Now you have this document to review, so hopefully that's helpful too. All right. All right, thank you so much for staying for a couple extra minutes today. I appreciate that. This is a great example, I think, 2 great examples of problems that you could definitely see on the AP exam. I would highly recommend looking over the code and asking me any questions if you do have any questions about the code. What else would I want to tell you? You could always go back and try the other free response questions that I've posted for you. That CodeHS resource has a ton of great free response questions that you could look up. You could find, they're all publicly available, the free response questions from previous AP exams, and work on those. The last thing I want to remind you is, again, you received via email that free response question that I am getting for a grade. Please make sure I get that by Sunday night. I don't want to accept any late submissions on that. That's plenty of time. That's 3.5 days to get it done. If you do have a question, you can feel free to pop into my office hours today, or you can ask me on Friday during that big long stretch of time, Friday afternoon, or Friday morning to afternoon, that I am going to be available for you. All right. Other than that, thank you for your attention and focus today, and I do hope you have a fantastic rest of your day and weekend, because I may or may not see you tomorrow. All right. Thank you, everyone.
Bye, Mr. Giorgio.
Bye, Mr. Giorgio.
See you later.
Thank you.
Have a nice day, Mr. Giorgio.
See you later.
Have a good day, Mr. Giorgio.
Later.
See ya, Giorgio.
See ya.
Have a good one.
See you later.
Why quit? There it is.